welcome. I'm Steve Reynolds, President Professor in the School of Earth and Space Exploration at Arizona State University and author of 3 textbooks for McGraw-Hill. McGraw-Hill has nicely funded these virtual field trips for us, and we wanted to do another one, in this case of Monument Valley. This field trip will be a little different than the ones we've done because we got the video crew to Monument Valley, but then a blizzard hit and I physically couldn't get there. So we shot the video and photos and immersive 3D resources up there, but then we'll add me later. So a lot of this will actually be me off the screen. You'll just be seeing the videos and the photos and things like that. But we wanted to start with just telling you what we're going to do on this. Monument Valley is along the Arizona-Utah border and has some really nice characteristics that make it a wonderful place to teach students how to observe landscapes and how to think about them. For example, take a look at this scene behind me and think about the different components that make up this landscape. Landscapes are kind of complicated, and so you have to kind of say, oh, this landscape's composed of this and this and this and this, and this makes it more comprehensible. Take a look at this image behind me. It's one of the Mittens for which Monument Valley is very famous. And for yourself, think about what components make up this landscape. And we'll let you do that for a bit, and then I'll talk about it. When you look at this landscape, it has just a small number of components. It has some layers that are best expressed down here in the pedestal below the mitten. And it also has some layers up in the mitten itself. There are some layers in the cliffy part, but you can't really see it. So there's layers, and there's a variation in the thickness of the layers. There's a very thick layer of sandstone up here, and very thin layers down here. In addition to the layers, there are fractures. There are a whole series of fractures here, and the fractures are mostly vertical in this case. That's really common for fractures. These are kind of fracture a joint. This is where the rocks are just pulled apart just a little bit. But even these little ledges down here have fractures in them. So those are 2 of the main components. In addition, you can see that there's the difference between rocks that are still attached, that is their bedrock, versus rocks that are loose and laying around on the surface. And so those loose rocks, that's another component. And when we look at something like that as geologists, we don't focus on every single rock. We say, oh, look, there's a pile of loose material. We typically use the term talus for this. And we just think of that as one entity, but that's just another component. And then the thing that's really cool about this particular image, at the very base of it, there's sand that's being blown around by the wind. And so that's another component of loose materials, not bedrock. Other components that you can look at in here is the colors of the rocks. And in this case, there's some kind of reddish browns in here. Students often describe these rocks as red. Turns out that very few rocks are red. When you think of red, it's a fire engine. These are not fire engine red. And then these are a little bit more brownish because these have a stain on them. In this case, it's a stain that we call rock varnish or desert varnish. And a lot of it's wind-blown, iron oxides, manganese oxides, other stuff that has kind of coated the rocks. And the longer the rocks sit there, the darker they get. But so the color, and in this case some of the desert varnish, is another component. And another component are the shape of the rocks. In this case, this is described as a mitten because it looks like a mitten. And so that's yet another component. And the shape of the rocks is just due to the intricacies of erosion and weathering, and it's related to fractures and how the rock's fallen apart. But so when you look at a scene like this, you can break it into its individual components. And I have to tell you, on the very first day of class, I teach students how to look at landscapes, because I'm going to be showing them landscapes the whole semester when I'm teaching in person. And so I want them to kind of be able to look at this. And then as we go along, there are other aspects that are important. For example, in this case, the layers are basically horizontal, but in some areas, they're not horizontal. And so that's another thing to look at. And likewise, here the joints are vertical, but in some cases they're not. They're at an angle or they're horizontal, and so that's another component to think about. So take a look at this landscape and think about it from the standpoint of the components. Taking something complicated and trying to extract the main essence out of it is a process called disembedding. Cognitive scientists use it. I've used it a ton. And so really what we're looking at is this is a disembedding process to try to say, what's the signal in here from all the noise? We don't have to pay attention to every single one of these little joints in this lower sandstone ledge. But we just want to say, oh, look, it's got joints, and this is the orientation, and maybe you talk about spacing and other things like that. One of the other things that we as geologists do with landscapes that we've never really recognized or taught students is we do something that I've named trading location for time. And if you look at a scene like this, we look at individual elements. Like here's one of the mittens, the same one we just looked at. There's another mitten. And then over here on this side, there's a mesa. And what we do as geologists is we look at those, and in our brains, we see an evolutionary sequence, either going back in the past or going forward in the future. So what we're doing, we're taking individual objects, features in the landscape, and we're kind of seeing how they fit in an evolutionary sequence. So that's what I mean by trading location for time. We're not around long enough to watch all this evolve, but if we see what these different landscape features look like, we can kind of build an evolutionary sequence. In this case, you can imagine that the earliest sequence in here of what we see here is this mesa. That these mittens were once part of a mesa. And so in the past, there was a mesa in here, and then you started eroding and separating them and isolating these mesas from one another. And there are places where this upper sandstone is gone, and you just have a rounded hill. And that's starting to happen out in here. And so you have these kind of three phases in the landscape. You have the mesa evolving to buttes, and as the resistant sandstone erodes away, you make little rounded hills. And so there are these three components, and we commonly use a scene like this in the textbook to illustrate trading location for time. But it's something we do, and it's helpful for students to realize that you can either go forward or backward in time. For example, we can say, oh, here's what it used to look like in the past, but we can also look at a scene like this and say, what's it going to do in the future? And in the future, once the sandstone cap's gone, then that will evolve into just a little rounded hill. As this mesa gets eroded, at some point there will be more isolated buttes. So you can either go forward or backward when you're thinking of this strategy.